Now on to systematic random sampling. Here we have to prove that variance of systematic sample mean is equals to capital N minus 1 by capital N into S square, capital S square, minus K into N minus 1 by N S square WSY, where S square Y is equals to 1 by K into N minus 1 double summation Yij minus Y bar I dot. For this particular theorem, we don't need to basically go too deep into any of the topics. We just need to know some formulas. That's it. We are going to use the sample mean square formula and we are going to use the variance formula. That's all we are going to use. So variance of y bar systematic is equals to 1 by k summation I is equals to 1 to k y bar I dot minus y bar dot dot minus y bar dot dot. Now we will consider the sample mean square, that is s square is equals to 1 by n minus 1 into double summation I is equals to 1 to k and j is equals to 1 to n I, and inside it will be yij minus y bar dot dot whole square, y bar dot dot whole square. Now we'll send this n minus 1 to the left hand side, so this will become n minus 1 into s square, capital S square, is equals to double summation yij minus y bar dot dot, y bar dot dot, and here everything again. Now inside we will add y. Now we'll add y bar I dot and we will subtract y bar I dot only inside this, then double summation yij minus y bar I dot plus y bar I dot minus y bar dot dot the whole square. Now we just need to expand this. This is a, this entire thing is a, and this is b. A plus b whole square. That's in the same way we will just expand this. So we'll write the summation outside, then double summation, we'll just write it outside for now, then yij minus y bar I dot whole square plus y bar I dot minus y bar dot dot whole square minus 2 yij minus y bar I dot into y bar I dot minus y bar dot dot, y bar dot dot. Now we will apply the summation inside. That will be I is equals to 1 to k, j is equals to 1 to ni, j is equals to 1 to ni, actually n, not ni. Then after we apply this, this should become yij minus y bar I dot plus summation, double summation again y bar I dot minus y bar dot dot whole square and 2 double summation yij minus y bar I dot minus y bar dot dot. In a similar way that on how these terms became 0 in the previous theorems, it's the exact same way here also it will become 0. If we apply the summation with respect to I, this will become 0. So this entire term will become 0. Then we will only be left over with 2 terms. That is, and also it is equals to s square double summation yij minus y bar I dot whole square plus double summation y bar I dot, here also I missed the dot, anyways, y bar dot dot whole square. Now this looks a little bit familiar. Here in the equation already they gave us double summation 1 by k into n minus 1 double summation yij minus y bar I dot. We already have double summation I is equals to 1 to k, j is equals to 1 to n. We already have part of this value. If we send only this k and n minus 1 to the left hand side, then this will become I'll write it here. Then this will become what? S squared WSY into K into n minus 1 is equals to double summation Yij minus Y bar I dot. Y bar I dot. This is what we had derived this. Now we will write that here. Because we already have a double summation Yij Y bar I dot. Then we'll write it here. S square WSY into K into n minus 1. K into n minus 1. Now plus. Even this value is a little bit similar. It is equals to the variance. Also here it is square. Okay, it is square. This is also similar. If we do not consider one of these summations, let's consider y is equals to 0 j n. Now there is no j values anyway, so this would become n, and summation k y bar I dot minus y bar dot dot. This will become, if we send this k to the left hand side, then k variance of y bar systematic. That's it. That's how it will be. K into variance of y bar systematic sampling. This is how it will be. And n minus 1 s square. Yes. Now if n into k, it is equals to capital N in systematic sampling, where because it is basically all the items and all the j terms are being multiplied, and then that would equal the population size basically. So s square WSY into k into n minus 1 plus n variance of y bar SYS. Y bar SYS. And this will be n minus 1 s square. All we have to do is divide this entire equation by capital N. That's all we have to do, and we'll get our proof. Divide by capital N. The dividing by capital N is simply to remove the n from here, so that we can send this value to the left hand side, and then we'll get this, and then we'll get this. So I wrote it in a new page. We divided this equation by capital N. That's all we have done. We divided it. Now then here the n and n will be cancelled. So n minus 1 s square by capital N is equals to s square WSY k into small n minus 1 by capital N plus variance of y bar systematic. If we send this term to the left hand side and then we rewrite the entire term, then it will become variance of y bar systematic is equals to n minus 1 s square by n minus s square WSY k into n minus 1 by capital N. That's all we had to prove. And then we'll also use this exact formula in the next theorem to basically prove another variance. That's it.